Okay, now let's take a look at another useful property. This property says the logarithm log a of r is equal to the ratio of log r over to log a, or ln r to ln a. Now, so the log r is a common logarithm. Now this is a logarithm when the base is 10. So log r is like log 10 of r, and log a is log 10 of a. And ln r and ln a, they are the natural logarithm. So they are the logarithm when the base is e. Now the advantage, so why this property is useful, because in the previous study or lectures we have seen that for the common logarithm and the natural logarithm, we are able to use the calculator to find them, right? So this property shows us for any logarithm, no matter what the base is, we are able to find such a logarithm by computing the ratio of these two. So from now on, we are able to evaluate any logarithm on calculator. So for example, we are given this logarithm log 3 of 41, and we're gonna use a calculator to find what does log 3 of 41 equal. So here the base is 3, so a equals 3, and this number is 41, so r equals 41. Now according to this property, this is equal to the ratio of, if we use the common logarithm, it will be log of 41 over log of 3. So next, we just need to use the calculator to find what they are, and then to find the quotient of them. So we type log of 41 on calculator and find log of 3. Okay. So 41 divided by of 3. So the result is this. Okay, if we round our answer to 4 decimal places, so it's gonna be 3.3802. And you will see, so here I'm using common logarithm. Now if I use the natural logarithm, I will get the same result. So this time, if I use the natural logarithm, I'm gonna use this. So let's find ln of 41 divided by ln of 3. So you can see the result is the same. So 3.3802. So here let me show you why this property is true. Why can we use this ratio, the ratio of the common logarithm or the ratio of the natural logarithm, to evaluate this one? So let's see. suppose we don't know what does this equal, so we let this be x, right? And we know when we convert this, when we rewrite this into exponent, so this is equivalent to when 3 raised to the power of x equals 41, right? Now, if let's see, if I apply a logarithm on both sides, for example, if I apply the common logarithm on both sides, so how can I do this? Because this is because of the first property we saw before. If these two numbers are the same, so when we apply the logarithm with the same base, the result gonna be the same. So here it's like I'm applying the logarithm with the base 10 on both sides. So therefore I can get have log of 3x equals log of 41. Also, you can try to apply the natural logarithm on both sides. Okay. And then, because the power of 3 is x, so if we apply this property, so now the p is x. If we apply this property, we can bring the x and put it in front of this logarithm. So we have x times the log 3 equals log of 41. So that's why if we, to solve for x, we divide by log of 3. So that's why we to find what does log 3 of 41 equal, we can find it by calculating the ratio of these